In continuing looking for patterns, you did this algebra puzzle today, and all of you were very successful with it. 3 ladybugs equaled 39, and you divided 39 by 3 to get that a ladybug was 13. And then you knew that these 3 ladybugs added up to 39, and you subtracted that 39 from 63 to get 24 for a flower. And then you added a ladybug, a 13, and a flower, 24, and subtracted that from 61 to get 2 popsicles, and then you divided it by 2 to get each popsicle was 12. And then what we looked at was if I changed all the ladybugs to X's and all the flowers to Y's and the popsicles to Z's, that's where it's like algebra. So really, this becomes 3x equals 39, and you do the same thing you did before. You divide 39 by 3 to get each x, which is 13. So we just continue looking in the problem-solving strategy, looking for a pattern. All right, and then we practiced a little bit for your quiz and checked your homework. And then I just had you take out some piles of tiles. Remember, the big square is an x squared because it's x by x. The rectangles are 1 centimeter by x, or the area is x, and little tiny squares are 1 by 1 tiles, so we call them ones. So we name the tiles by their area. So these are x squareds, these are x's, and these are ones. So I had you pull out some groups of tiles, and we just practice writing an algebraic expression for the tiles. So 5 big squares was 5x squared, 4 rectangles was 4x, 13 little squares was 13, and then we practiced the distributive property. If I had 4 groups of those, you told me how many of each tile I would have. We'd have 20x squareds and 16 x's and 52 little tiles. So we use the tiles as concrete things you could actually feel and count. Okay, then you examined all these to see why are both of these terms like terms, and these are like terms, and the red ones are like terms, and the blue ones are like terms. And you guys figured out it's because their variable parts are exactly the same. Same variable and the same exponent. Same variable parts. As long as the variable parts are the same, they are like terms. These are unlike terms because x is not the same as t cubed. P is not the same as x. C squared is not the same as c to the fifth. 27 times c to the fifth means this. 20 times c squared means this. These are not the same size tiles. And x is not the same as xy. So in order to be like terms, they have to have the exact same variable part. And why is this important? Because when you're combining like terms, you have to know, can I add them or not? So these are like terms. I can add 5 of this size tile and 14 of this size tile gives me 19 t cubes. The t cube is the size of the tile. 19x minus a negative 2x becomes 19x plus 2x, which is 21x. And 20 groups of c to the fifth plus 27 groups of c to the fifth are 47 groups of c to the fifth. And this was 15xy's minus 23xy's. So it becomes a 15xy plus a negative 23xy, which is a negative 8xy. All right, next you worked with finding the perimeter of a trapezoid, which is just combining like terms. So you added them all up and got 15.2x's. And then I said, what if this was ribbon that I needed to put around here and I had 10 packages in this shape? So how do I multiply 10 groups of 15.2x? And you just multiply 10 times 15 and 2/10. That's 152, and there's still x's there. They're all still, that's the same size tile, just the rectangles. And then we just practice with some other variable expressions. So if the length of this side of this quadrilateral is 4u, and the length of this side is 50u minus t, and this side is 7u, and this side is 2t plus u, how do you find the perimeter? So we talked about using the commutative property. So just add up all 4 sides, and then rearrange them so you have all your u's together and all of your t's together, and just combine your like terms. So the best I can do to call this perimeter as one algebraic expression is 17u plus t. And then I said calculate the perimeter if u is 25 and t is 10. And some of you thought it's easier just to do each side. So 4 times 25 is 100, and 5 times 25 minus 10 is 115, and 7 times 25 is 175, and 2 times t plus u is 45. And we talked about, is it easier to do that and add those four numbers, or is it easier just to use your simplified algebraic expression and do 17 times 25 plus 10? Most of you agreed this is easier. So combine your like terms first and then substitute and simplify. The perimeter is 435 units. Vocabulary coefficient is just the number of tiles you have. So in 8x, 8 is the coefficient. In 23xy, 23 is the coefficient. And in 9x squared, 9 is the coefficient. So it literally is just the number part of the variable expression, or how many tiles you have. And then the reason why you want to know like terms is so you can combine them. So I can add these and I have 25x's. I can subtract these and I have 8xy's. I can add these and I have 24x squareds. And be careful. The variable parts have to be exactly the same exponent. These are not like terms and you cannot add them. Just because the coefficient is the same, if the variable parts are not exactly the same, they cannot be combined. So I cannot simplify that. 3x squared plus 3x to the 11th is as simple as I can get it. And then we practiced combining the distributive property with combining like terms. So first you needed to expand this one. So 8 times 4x is 32x. 8 times x squared is 8x squared. 8 times 5 is 40. And we're adding it with these. So I circled the x squareds. 3x squared plus 8x squared is 11 of those big square tiles. And we had 1x and 32x's. 1x and 32x is 33x's. And 2 plus 40 is 42. So in simplest terms, we have 11x squareds plus 33x plus 42. And then we practice it again. So first you expand. So 10 times 12x is 120x. 10 times a negative x squared is negative 10x squared. 10 times negative 3 is negative 30. And then you had to put that together with your 4x squared, your x, and your 9. Oh, this got a little cut off. Scoot it over. And so we can put all our x squareds together. So negative 10x squared plus 4x squared is a negative 6x squared. 120x plus x is 121x. And negative 30 plus 9 is a negative 21. So you want to combine all those like terms. All right, this is what you need to do for practice for homework. It's a 2-day week, so I need 1 hour in ALEKS and 5 topics by Thursday. And then just make sure that you see that if you're close to finishing the orange and the green sections of your pie, I'm going to shorten those amount of topics a week as soon as those are completed. So I'll just tell each of you individually.